Hey everybody, we're on 10.2 trig ratios with a missing side. So we're going to add up, we're going to keep doing what we did on our last lesson, but what? A side is missing, so how are we going to do that? All right, so if we're missing a side, like looking at example A, you've learned how to do this before. And if you recall, that is called the Pythagorean Theorem. So if we're missing a side, and we have two sides and we're missing one, we can use the Pythagorean Theorem. I hope I spelled that wrong. I always spell it wrong, so be patient if I do get it wrong. So that's a squared plus b squared is equal to c squared. All right? So let's do an example together. All right, so let's say this is A and this is B and this is C. We want to find that missing side, so we would just use the Pythagorean theorem. So 12 squared plus 16 squared is equal to C squared. I would use my calculator. 12 squared is 144. 16 squared is 256. Maybe combine like terms. That gives me 400 equals c squared. And then if we want to get rid of a squared, again, the inverse of that would be a square root. And would end up getting c is equal to 20. All right? Why don't you give this one a try if you haven't yet. Again, this is our A, this is our B and C. All right, so one thing is if we're doing the Pythagorean theorem, we need to square all of what we say A is. So if you're going to use your calculator, you make sure you put a parenthesis and then square it. If you don't have the parenthesis, it's only squaring the square root of 7. It's not squaring the 6. So keep that in mind. And then we'll do 18 squared is equal to c squared. So if we square this, it's basically 6 squared. Well, that's 36. And let's look at that. So that's like 36 times, well, the square root of, or the square of the square root of 7 would give you 7. And then we can multiply that together. Best just use your calculator, and you'll end up getting 252. Okay? And 18 squared is 324 is equal to c squared. Combine like terms, 576 is equal to c squared. And then, again, the inverse of squaring is the square root. And we would get c is equal to 24. All right, so there's a quick review of using the Pythagorean theorem. And why would we want to use that? Well, let's do an example like we did last time. So here's our reference angle. This is our hypotenuse, opposite, and adjacent. And they want us to find the trig ratio for tangent of theta. That's opposite over adjacent. Opposite over adjacent. What? Oh, but we don't have the opposite, so that's why we'd probably want to use the Pythagorean theorem. All right, so I guess we probably need to figure that out. Just be cautious, because when we do a Pythagorean theorem, it's like A, B, and C, and now we have A, H, or O, and O, A, and H. So just keep that in mind when you do it. So we have like 8 squared plus like B squared, this is like our opposite side that we're missing, is equal to C squared. And also remember too that C squared for the Pythagorean theorem, C is always your hypotenuse. So we always need to use that for our hypotenuse. All right, so 8 times 8 is 64 plus B squared is equal to, and C, we know what C is. C is our hypotenuse, which is 17. So 17 squared is 289. Again, just use your calculator. We need to get B by itself, so we could subtract 64. That gives us 225. And then, again, the inverse of a square. The opposite of squaring is the square root, so b is equal to 15. But are we done? Well, we just figured out that this side is 15. So now when we write down our ratio for tangent, we would get 15 over 8. And then we're done. So if we wanted to write that over here, we could do that. So tangent of theta is opposite over adjacent, which is 15 over 8. All right. Okay, so let's try this one again, or try this one, and maybe you guys could pause and give a try on one or two of them and see how you feel. All right, so again, that's our reference angle, that's our opposite, adjacent, and our hypotenuse, our longest side. So we need to find what c is, that hypotenuse. So we'd do like 10 squared plus 15 squared is equal to c squared. So that's 100 plus 225 is equal to c squared. That's 300. 325 is equal to c squared. And then we will square root both sides, and we'd get c is equal to the square root of 325. Okay, so you could put that in your calculator. Most likely it will give you a decimal that keeps going forever. So we need to simplify our radical. And we've done this before, I think it was last semester. So that's where we did like the factor tree and groups came out. So we could do something like 5. I know 5 goes into that. It goes into it that many times, and we have 65 left over. And I know 5 goes into 65. That leaves us with 13. So here we have a group of 2. Again, basically that's basically the square root of 25 times the square root of 13, or the square root of 5 times 5. So that's why we can take these groups of 5s out. So we'd end up getting 5 square roots of 13. All right, so now that's reduced, and we can write down our ratio for sine. So sine of theta is, so that's opposite over hypotenuse. So opposite is 15, and the hypotenuse, which we just found, which was 5 square roots of 13. And then you notice that we have a root in the bottom, so we need to rationalize it by multiplying it by 13 square root, or the square root of 13 over the square root of 13. And that will give us 15 square roots of 13 over 5 times 13. Guess I kind of did this a little different last time. We can simplify that right now and get 3 square roots of 13 over 13. All right. All right, so I have a couple more examples on that. If you feel comfortable, there's nothing any really different for C and D. You can kind of skip over to the next page if you need to, but I'm going to give you a couple more examples. So here we have a missing side. My guess is we're going to need to find it by using the Pythagorean Theorem, because katoa, adjacent over hypotenuse, we're missing its adjacent side. So let's do that then. We have a squared plus b squared equals c squared. So we could do a squared plus 4 square roots of 2 squared is equal to 9 squared. So here we have a squared plus, and here you could just plug that into your calculator, but 4 squared is 16, and the square root of the square root of 2 is 2, so that's 32 is equal to 81. We can subtract the 32. A squared is equal to, looks like 49, and that's a nice number. Square root both sides, we get a equals 7. Again, that's not our answer yet. That's just a spot on the way. So cosine of theta is adjacent over hypotenuse, which is 7 over 9. Okay, and then one last one. I'll just do it really quickly. Okay, we need to find this side. So a squared plus 9 squared is equal to 9 square roots of 5 squared. That gives us a squared plus 81 is equal to, well, that's 81 times 5, which is 405. Subtract the 81 over, that gives us 324. And then we'll square root both sides, we get a equals 18. So then we can do the tangent of theta, which is opposite over adjacent, is 9 over 18, or 1/2. All right, so that's basically half of what we're covering. It's the majority of the stuff we're covering. All right, and the last thing we need to talk about is problems like this. So they want us to find the trig ratio, kind of shown a little different. In the past, we gave you like a triangle, and we needed to find the ratio, but now I'm giving you the a ratio, and we need to find a different ratio, all right? So basically for all these types, we kind of want to draw the triangle we're going to use rather than be given to one, all right? So this could be our theta. It doesn't really matter if you choose that one or this one. Just choose one of them. Again, we know cosine is, so ca, adjacent over hypotenuse. So if this is our reference angle, adjacent is here, so that would be square root of 2, that's adjacent. And then our hypotenuse is on this side, and that's our bottom, which is 2. Okay? They want us to find the sine of theta. Well, sine is opposite over hypotenuse, so we need to figure out what the opposite side is. So now we're back to where we were before. So we could do the square root of 2 squared plus b squared is equal to c squared. And that gives us 2 plus b squared is equal to 4. And we can solve for b, subtract 2 to both sides. We get b squared is equal to 2, or b is the square root of 2. So when we do the sign of opposite, this is saying that's the square root of 2. So we'll do the square root of 2 over 2. And actually, for this problem, the ratio is the same. Cosine of theta is the same as the sine of theta. And we'll probably talk about that a little bit with this. This is kind of like a special triangle. But we kind of need to talk about what the angle is. And we'll talk about that in a minute, or later on. All right, so here's another example. Again, feel free to pause and give this a try. So here's my reference angle. Again, tangent is opposite over adjacent. This is our opposite. This is our adjacent. This is hypotenuse. Okay, so opposite is 3, and adjacent is 4. And they want us to find sine of theta, which is opposite over hypotenuse. So, okay, so again, we need to do the same thing. So 4 squared plus 3 squared equals c squared. That's 16 plus 9, which is 25. So c is 5. This is kind of a special triangle, 3, 4, 5. So our opposite is 3, and our hypotenuse is 5. And that would be our ratio. All right, so it looks like we have a root in one of these, so that might be good to go over and try that. And then D, again, if you're feeling comfortable, feel free to practice it, go to the answer part, check and see how you're doing. All right, so again, helps to draw first. Here's our opposite. Oops, I almost wrote an A. Opposite, adjacent, hypotenuse. Sine is opposite over hypotenuse. That's our SO. So we got, what, square root of 7 and 4. And then we need to figure out, well, you guess we're probably going to need to figure out what the adjacent is. Okay, because cosine is adjacent over hypotenuse. So we know what the hypotenuse is already. We just need to find the adjacent. So we could do the square root of 7 squared plus b squared is equal to c squared, which is 4 squared. Again, that gives us 7 plus b squared equals 16. Subtract the 7 over, and that gives us 9, or b is 3. So there we go. Because that wasn't too bad. All right, and last but not least, if you want to do this, actually this one is also one of those special triangles. Sine is opposite over hypotenuse, which is 4 over 5. Okay, so we need to figure out what the adjacent is. So 4 squared plus b squared is equal to 5 squared. So that's 16 plus b squared is equal to 25. And we'll subtract 16 from both sides. So here b is 3. Again, this is one of those special triangles, 3, 4, 5 triangle. All right. So what should we do in these situations? We should always draw it. Draw the triangle. I guess that's not a right triangle. We should draw a right triangle. All right. Well, if you have any questions, let me know. We'll see you later.